All right, guys, so let's go ahead and take a look at your net force calculations. There are only 5 problems today. 1 and 5 are just simple calculations. You have a diagram here, and you just have to answer what the overall force is. So we can do number 1 together really quickly. So you have your force diagram. Remember, you always have the force of gravity working down and the normal force working up, but they equal each other, so we don't have to worry about those. You have a 5 Newton force working in the leftward direction and a 25 Newton force in the right-hand direction. So with force diagrams, if the forces are in opposite direction, you just have to subtract them. Okay, so 25 newtons minus 5 newtons is 20 newtons. Okay, so that's our answer to number 1. So that's all we have to do for that one. Now the last one, this one right here is the same thing, but remember, if they're going in the same direction, you have to add them. So for this one down here, these two forces moving in the right-hand direction or towards the right, you'll add 61 plus 192, and then you'll have to subtract this force that's moving in the opposite direction. Okay, so for this one, you'll do 61 plus 192 minus 61, and you'll tell me your answer there. Okay, so those are pretty quick. Now for 2, 3, and 4, we have to draw our force diagrams and then calculate the force, okay? So I'll do number 2 with you, and then you guys will do 3 and 4, okay? So 2 says, a man slides down a pole with 500 newtons of force. The opposing friction is 200 newtons. Draw the force diagram and calculate the net force, okay? So we're going to go to Insert, and we're going to go to drawing because you're going to have to draw your force diagrams from your Google Drive. Okay, so, and I have 2 copies here just so we can keep it up, just to make it a little bit easier to read everything. But I'll move this over. All right, so it says that the man slides down the pole with 500 newtons of force. So remember, in a force diagram, it doesn't matter what the object is. We can just represent it by a box. So I'm going to choose a shape. I'm going to go to shapes, and I'm just going to choose a square, and I'm going to put my square into the drawing. Okay? Doesn't really matter where. And then you can see that it's going to pop up. So it will, when you insert your drawing, it will appear into the answer box for you. Okay? And so we have the man, he's sliding down the pole, right? So he's sliding down a pole, so the force that's working in towards the pole is going to be 500 newtons. So I'm going to grab an arrow, and I'm going to draw the direction that the man's moving, which is down the pole. Doesn't have to be perfect, just has to be in the right direction. And that's going to be 500 newtons. So I'm going to just insert a text box really quick. And it's going to be 500 newtons. Okay, I'm going to put that by my downward force because that's his force that's working. Okay, and we know that the force of friction, so that is opposing him on the pole, is 200 newtons. Right, so I'm going to get another arrow. So I'm going to go to select line or arrow, and I'm going to draw my force of friction upwards. Okay. Then, of course, I'm going to get my text box, and I'm going to type in my 200 newtons, because that's the force of friction as he comes down the pole. Okay, so in the downward direction, he's got a force of 500 newtons, and in the upward direction, he has a force of 200 newtons. We're assuming that there's no forces in the left or the right-hand direction. Okay, so once we're done with that, you can click, I think it's save and exit is that blue button. And then your diagram will be there so I can see it. Okay, so that's A, was to draw the force diagram. B is to calculate the net force. Okay, so again, these net forces are in opposite directions. So whether they're pushing against each other or pulling away from each other, you subtract. So 500 newtons minus 200 newtons is 300 newtons. Okay, so that is the answer to number 2. So you've got your force diagram, and you have your net force there as well. So that's how you insert a drawing and you complete your force diagram. You just have to use, the only three things you have to use are the shape box, the arrow box, and then the text boxes to put in your forces, because you do want to make sure you have your forces labeled correctly, because that will help you calculate your net force. Okay, so you'll do that for 3 and 4, but please pay attention. 3 and 4, you're moving on the left-hand side, so you're going to have forces pushing and potentially pulling, so just make sure you're drawing your arrows correctly. For 3 and 4, you don't have to draw the force of gravity or the normal force, okay, because they're moving the objects. They're sliding them either to the left or the right. I don't want you to have to worry about drawing the arrows for the gravity and the normal force, so you can just draw the arrows to the left and to the right. Okay, so just like I drew it up and down in 2, you can draw it to the left and the right in 3 and 4. Now, number 3 says, does the refrigerator move? Or for C, 3C says, does the refrigerator move? It's having these 2 people pushing their refrigerator. The force that they apply has to overcome the friction force of 100 newtons. So if the total force that the man and the wife apply on the refrigerator is more than the friction force of 100 newtons, then it will move. Okay, so if your calculated force that they're pushing is greater than 100, the answer would be yes. If it's less than 100, the answer will be no. Okay, and I think that's pretty much it. That's the nitty-gritty of this one. I know using Google Drawings can be a little bit tricky, and of course physics itself can be tricky sometimes, so if you're having trouble, please do not hesitate to let me know, and I will definitely hop on and help you with this one. Okay, so I will catch you guys in your next lesson. I hope you all have a great day.